Question number 4 asks us to find the equivalent resistance of the circuit and the current going through each of the resistors. To start, let's redraw this circuit as if there were only one resistor in it, and we can use that model to find the equivalent resistance. So we've got our battery, got one resistor, and so that's a very simple, basic circuit there. And so this Req is going to be the equivalent resistance of the circuit that we're looking for. In order to find this equivalent resistance, we're going to need to combine all 4 of the resistors in the circuit into one resistor using what we know about parallel and series resistors. To find this equivalent resistance, we're going to need to use what we know about parallel and series resistors. So a little refresher I've written down below. We know that the equation for our equivalent parallel resistors is 1 over the equivalent resistance is equal to 1 over R1 plus 1 over R2 and so on. And for series, it's very simple. You just simply add them up, R1 plus R2 and so on. So if we look at this circuit here, we can see that R2, 3, and 4 are all in parallel. So we're going to need to use that parallel equation to find the equivalent resistance between them. So we can say that 1 over R2, 3, 4 is equal to 1 over R2 plus 1 over R3 plus 1 over R4. Adding in the numbers, we get that that is equal to 1 over 50 ohms plus 1 over 50 ohms plus 1 over 75 ohms. If we combine all those, we get that is 16 over 300 ohms, and that is equal to 1 over R234. So we get that R234 is equal to 300 over 16 ohms, which is equal to 19 ohms. Next, let's redraw the circuit again, this time with our R234 and our R1. So we've got R1 here and R234. And so those are in series, and so that'll just be some simple addition. And that'll give us our Req. So our Req is going to be equal to R1 plus R234, which is equal to 100 ohms plus 19 ohms, which is equal to 119 ohms. And so that is our equivalent resistance for this circuit. For the second part of the problem, it asks us to find the current in each resistor. So let's go ahead and label each of those currents. We've got I1 going through resistor 1, I2 going through resistor 2, I3 through resistor 3, and I4 through resistor 4. Starting with I1, we can see that that is the one that flows through the battery. And so we can use the equivalent resistance to solve for it. So using that circuit here, we've got our voltage from the battery is equal to 6 volts. We've got I1, and we know our equivalent resistance is 119 ohms. And using our Ohm's law, we know that V is equal to IR. And so I is equal to V over R, which is going to get 6 volts divided by 119 ohms, which comes out to just about 50 milliamps. In solving for the next 3 currents, it's important to note that the voltage drop across parallel components is always equal. And since resistor 2, 3, and 4 are parallel, we know that the voltage drop from this top node down to the bottom node is going to be the same for all 3. And so we can create kind of one voltmeter, you could say. And so the voltage drop across all 3 of those will be the same. We can call that V. And from that observation, we can figure out that that V is equal to I2 times R2 is equal to I3 R3 is equal to I4 R4. Solving for that V, we can use our I1, which is flowing through that equivalent resistance of R234. And we know V equals IR, V equals I1 times R234, which is 50 milliamps, times that equivalent resistance of R234, which is 19 ohms. And that is going to get us about 0.95 volts. Finally, we can use Ohm's law to calculate for each of those individual currents. And so we know that I2 is going to equal that V divided by R2. I3 is equal to that V divided by R3. And I4 is equal to that V divided by R4. Adding in some numbers, we get that 0.95 for each of them. And then for our 2 and 3, we know those are both equal to our 50 ohms. And our 4 is 75 ohms. And so that'll leave us with 19 milliamps through I2, or through R2 and R3. And 12 milliamps through I4, or through R4. The I4 is equal to 12 milliamps. And as a way to check our work, we can use KCL, Kirchhoff's current law, which tells us that the sum of all the currents going into a node is equal to the sum of all the currents going out of the node. And because of that, I1 has to equal I2 plus I3 plus I4. And in this case, it works out 50 is equal to 19 plus 19 plus 12. And so that's how you do this one. Hope that helped.